All right, I'm going to try a new video method and hopefully it looks a little bit better. This lesson is on simplifying rational expressions and excluded values. And so you should, of course, as always, be taking notes in your notebook and writing down any questions you might have for next class. So we're going to start with what an excluded value is and how it comes into simplifying. We're going to look at the function y equals x over x. And we're going to make a graph of it. But before we make a graph, let's start making a table. And you might see where this is going very quickly, or at least mostly where it's going. I'm going to pick -3, -2, -1, 0, 1, 2, 3. Okay, cool. So when x is -3, when we do -3 over -3, we get 1. Okay, anything divided by itself is 1, mostly. When we put in -2, we get -2 divided by -2, and -2 divided by -2 is also 1. And you might think to yourself, well, okay, x divided by x will always be the same thing divided by the same thing. If we put in like 1,000, you'll get 1,000 divided by 1,000, and that will also be 1. Even if you put in something like 0.57, you'll get 0.57 divided by 0.57, which is 1. But there is one exception, and that's at 0, because when we do 0 divided by 0, 0 divided by 0 is not 1. This is undefined because we're dividing by 0. And so this graph ends up looking very weird. The values come out to be 1 everywhere except 0. So here is 1. And the graph ends up looking like this, where as you go to -infinity, you stay at 1. As you go to positive infinity, you stay at 1. It doesn't matter what x value you're at. If you put in pi, pi divided by pi is 1. But at x equals 0, there's what's called a hole. And this is an excluded value where x cannot be 0 for this function. So we can say the domain for this function is all the numbers between -infinity and 0, union all the numbers between 0 and infinity, but not 0. This is a way of writing, saying like, hey, all the numbers between 0 and 0, -infinity and 0, but not including -infinity or 0. And so this has all the numbers except for 0 in it because you're not allowed to divide by 0. And that's called an excluded value. Is x equals 0. It's not a value in the domain. Excluded means left out of. And so 0 is the number that is left out of the domain. And so what's interesting is that this function, and we'll talk about this more next class, this function is y equals 1 as long as x does not equal 0. So the function is just y equals 1, which is a horizontal line, but only when x is not equal to 0. When x is equal to 0, there's no value, it's undefined. So that's what we mean when we say excluded values, is numbers that are not in the domain. So numbers not in the domain, numbers that are undefined. And in rational functions, it'll happen whenever we divide by 0. So let's look at how we can use this idea to simplify some things. So we're going to start with something like y equals x squared plus x divided by x squared minus 1. And I want to be very careful here to point out that I see sometimes people try to cancel out this x squared and be like, oh, there's an x squared divided by x squared, that goes away. It does not. That is not true. If you have 5 plus 1 divided by 5 plus 7, you cannot cancel out the 5. This is bad. No, don't do this. Okay, because 6/12 is 1/2. But if you canceled out the 5s, you would get 1/7. And these are not the same. They aren't the same. You can't do this. Please don't ever do this. And I know some of you will anyway. You can't cancel out these x squareds. What you can do is we can factor. And you'll see how this is going to allow us to simplify in a second. You might want to pause this for 5 seconds, give yourself a chance to make sure you can factor both the numerator and the denominator, and then unpause the video. Okay, Hopefully you were able to factor it. The top one has a common factor of x, so we can factor out an x times x plus 1. The bottom one is the difference of two squares. It's a special trick where it's x minus 1 times x plus 1. Negative 1 times 1 multiplies to be negative 1, and negative 1 plus 1 adds up to be 0. There's no x's here. And now we'll notice that there is an x plus 1 on top and an x plus 1 on bottom. And I claim that you can now cancel these out. And the difference from before, why we can cancel these out, is because x is getting multiplied by x plus 1 and then getting divided by x plus 1. Multiplying and dividing are inverse operations, and so this will cancel out mostly, okay? What's going to happen here is this is going to equal x over x minus 1, but x cannot equal negative 1 or 1. We already can tell from this that x can't equal 1 because 1 minus 1 would be 0, and you would be dividing by 0. These are what's called the excluded values, and even though we simplified it, in order for this to be equal to this, we have to state that x can't be equal to negative 1. Because when we plug in negative 1, what we would get is 0 divided by 0, and that is an undefined value. And so when we factor and cancel something out, we always need to make sure we state the excluded value of the thing we canceled out. Otherwise, they won't be equal to each other. Basically, this more complicated one will equal this as long as x doesn't equal negative 1. When x is negative 1, this one will be undefined, but this one won't be. Let me give you an example. If we put in the number 5, we get 5 times 5 plus 1 is 6, divided by 5 minus 1 is 4, times 5 plus 1 is 6. And 5 times 6 is 30, 4 times 6 is 24, so 30 over 24, which is 5 fourths. We can divide both by 6 and get 5 fourths. Or we could have seen right here that multiplying by 6 and dividing by 6 cancels out and gets you 5 fourths. If we plug it into this one, if we plug in 5, so this is when x equals 5. If we plug in x equals 5 into this one, we just directly get 5 fourths. And we can see how the simplified one is much easier to use. When we plug in 5, it's way faster to get to 5 fourths, but they're the same. The only exception is when x is negative 1. When x is negative 1, in this one, we get negative 1 times 0 divided by negative 2. Negative 1 minus 1 is negative 2 times 0. And this is 0 divided by 0, which is undefined. But if we try to plug in negative 1 into this one, we get negative 1 over negative 2, which is 1/2. And 1/2 and undefined aren't the same. And so in order for these to be equal, we need to make sure we state the excluded value. I'm going to do one more quick example. Let's say we have x cubed minus 5x squared minus 6x over, x squared minus 36. So I want to simplify this as much as possible and state any excluded values. This is what your homework is. We're going to simplify as much as possible and state any excluded values. And in this top one, we can start by, we're always going to factor the numerator. So step 1 is always going to be factor. We're going to factor both the numerator and the denominator. You might want to pause this and see if you can do it yourself. It's always a good idea to try to do this as you're going along. So I'll give you a second to pause the video, try to factor both the numerator and the denominator yourself, and see what's coming ahead. See if you can see how it will simplify. So this is x times x squared minus 5x minus 6 divided by, this is the difference of two squares. It's x minus 6 times x plus 6. When there's no x in the middle, we know it's going to be positive 6 and negative 6. That way when you add them up, you get 0 x's. And then the numerator can be factored even more. We can factor this out. So there's still an x in the front, but this can factor into x minus 6 times x plus 1. These multiply to make negative 6 and add to be negative 5 over x minus 6 times x plus 6. And what we can see here is that there is one factor that can cancel out. The x minus 6 can cancel out because, again, we are multiplying by x plus 6, x minus 6, and dividing by x minus 6. And multiplying and dividing are inverses of each other. And so this whole thing is equal to x times x plus 1 over x plus 6. And if I wanted to, I could simplify the top and get x squared plus x over x plus 6. But I need to state the excluded values. One excluded value is when x equals negative 6, and that's because when x is negative 6, negative 6 plus 6 would be 0, and dividing by 0 is undefined. So x cannot equal negative 6. This is an excluded value. Excluded value. But there's another excluded value, which is the factor I canceled. X cannot equal 6 also, because when x is 6, 6 minus 6 was 0, and we would get 0 over 0. And so even though that factor canceled out, it's still an excluded value of this original one. Okay. Another way I could write this is I could say the set of excluded values is negative 6 and 6. Okay. So why don't you guys try one on your own? Why don't you try, let's do x squared minus x minus 20 divided by x squared plus 7x. Hold on. No. X squared minus 7x plus 10. I apologize. And so you're going to try to see if you can both simplify it and state the excluded values. Pause the video, see if you can do it, and then unpause the video and I'll go over it. All right. The first thing to notice is we cannot cancel out x squared because even though it looks like they're the same, subtracting is not the inverse of dividing. Subtracting and dividing don't cancel each other out. They are not inverses. And so we cannot cancel out the x squared, nor can we cancel out the x. To be able to cancel things out in a rational function, we need to factor. So hopefully you were able to factor the top. This factors into x minus 5 times x plus 4. The denominator factors into x minus 5 times x minus 2. The top ones, these multiply to make negative 20 and add to be negative 1. The bottom ones, these multiply to be positive 10 and add to be negative 7. And so this can simplify to x plus 4 divided by x minus 2. And this is the simplified form, but the excluded values we always need to state, especially when we cancel something out, is the excluded values are going to be 5 and 2. And the reason we can't have 5 or 2 is because they make the denominator 0. Notice there's no problem with x equals negative 4. We can have negative 4 as a value for x because when x is negative 4, we get 0 divided by something. And it's okay to have 0 divided by, in this case we get, positive 54. 0 divided by 54 is 0. It's not undefined. But if we had gotten something like 54 divided by 0, that's undefined. So you can't divide by 0, but you can have 0 divided by something else. This is okay, this is bad. So the excluded values are just what values make the denominator equal to 0. Okay, so denom equal to 0. So in your homework tonight, you've got a bunch of ones where you're going to be factoring and canceling out and stating the excluded values. I'd like to point out one more thing we can do. We can do crazy stuff like x squared minus x minus 6 divided by x squared minus 4 divided by something like x squared minus 9 divided by x minus 2 or something like that, okay? And this looks kind of crazy, but we can use our same idea here. And our idea is we know how to divide fractions. The way we divide a fraction is we leave the first one alone and we change it to a multiplying problem. Dividing by something is the same as multiplying by the reciprocal. So the x minus 2 becomes on top. And now we can factor everything and multiply across. This top one factors into x minus 3 times x plus 2 times x minus 2. This factors into x minus 2 times x plus 2, because this is a difference of 2 squares. And this one factors into x minus 3 times x plus 3. and they're all multiplying together. And when you multiply, you just multiply straight across. So it's this times this and this times this. So it all becomes a single fraction. And now we can cancel a bunch of things out. Multiplying by x minus 3 cancels out with dividing by x minus 3. Multiplying by x plus 2 cancels out with dividing by x plus 2. Multiplying by x minus 2 cancels out with dividing by x minus 2. And if there's nothing left on the top, you should remember from Algebra 1 or from middle school, we need a 1 there. This is the same as 1 divided by x plus 3, but x cannot equal anything in the excluded value set, anything that makes the denominator 0. So 2, -2, 3, or -3. And so that is going to conclude our lesson on excluded values. Hopefully you feel pretty good about how to factor, cancel out the factors that are the same in both the numerator and denominator. But any factors we cancel out, we need to make sure we are still stating those excluded values, because it looks like you can plug in 2 to this. 1 divided by 2 plus 3 is 1/5, but if we plug it back into the original one, we would be dividing by 0. And so it is an excluded value that we're not allowed to have even when we simplify, because we want the original to be equal to this, and to have that be true, we need to state all the excluded values from the original one. So that's anywhere where the denominator of the original one was 0. Okay, good luck. And if you have any questions, obviously write them down now and ask in our class on Monday.